Hi, everybody. It's Dr. Z, and we are here in chapter 16. We're going to be talking about the scientific revolution, and there's going to be two parts to the scientific revolution in these videos. So, one of the things to think about is, where did this come from? Of course, the Greeks in the Renaissance were a precursor to the scientific revolution. Classical science, in its own way, in the classical world, in the ancient world, science was intertwined with religion. Science explained the unexplainable. And as we know, the classical Greeks and Romans were wondering about astronomy and the planet and all sorts of different things. So that, of course, that connection to the Renaissance from the classical world also ties in. This is sort of a third stop along the way in the journey of human understanding. But in this time period, and we are, in the 16 into 1700s, we are looking at public science. It's not academic. This is not happening in universities. This is happening, the kings and nobles are paying for this science to happen, and creating scientific academies, but don't think academy in the sense of a university. Think of it as a place where scientists come together and create laboratories and do experiments. And these scientists called themselves natural philosophers. And this was sort of a connection to that ancient classical history that they had. The other side of it was that a lot of these scientists were religious. As we're going to see, they were looking to not disprove the existence of God, but to explain God's world and to prove the existence of God. That sort of was the pie in the sky ultimate task of these natural philosophers. So when we think of the scientific revolution, we should think of a couple things. One is the scientific method, which surely you have learned in your science classes, and also that some advanced mathematics come about at this time. I'd maybe add another one to that, and that's astronomy. Astronomy is quite large at this time, as well as anatomy as well, and we'll explore some of that together. So your key concepts from the AP Gods: one is the rediscovery of works from ancient Greece and Rome and observation of the natural world change many Europeans' view of their world. And of course, we remember, we are coming from the period when Europeans go in their first wave of colonization to the Americas. So that certainly is a catalyst for the scientific revolution. Likewise, our AP Gods tell us that new ideas in science based on observation, experimentation, and mathematics changed classical views of the cosmos, nature, and the human body, although existing traditions of knowledge and the universe continued. So they were building on what the classical philosophers, natural philosophers in ancient Rome and ancient Greece were saying, but also keeping some of those traditional views from that period, but also from the Middle Ages and the Renaissance. So before 1500, the medieval world had what was called philosophy, the path to knowledge about the world. It's very vague and much more vague than what we think of as philosophy today. So ancient scholars were the authority on this. And when we think of philosophy, we think of Greek philosophers and Roman philosophers as well. Likewise, when we get into the Middle Ages, we think certainly of the Muslim world, and later on a bit with Christian theologians who are starting to interpret this, leading into the Renaissance. Natural philosophy, of course, in the 1600s then was questions about the physical nature of the universe. And this was seen as a minor branch of philosophy, even in the era before the Renaissance as well. Natural philosophers drew on scholarship from the medieval Muslim world and based their ideas on classical ideas from Aristotle. And so science then, the word science, starts to emerge in the 1800s. So we're not quite there yet. Yes, this is the scientific revolution, but at the time, folks like Newton, who we'll talk about, would have seen themselves as natural philosophers. So what was Aristotle's view of the universe then? So he was a medieval theologian, Thomas Aquinas. So he's a European Christian. And he brought Aristotelian philosophy into harmony with the Christianized view of Aristotle. So what was this view? the earth was motionless. It stood at the center of the universe. And yes, this is wrong, okay? But this is the whole idea, is that we're proving this wrong in this time period. But before the scientific revolution, this is what they thought, that the earth was in the middle of the universe. It was geocentric, and was encompassed by 10 separate concentric crystal spheres in which were embedded the moon, the sun, the planets, and the stars. Beyond the stars was heaven, with the throne of God and the souls of the saved. And angels kept these spheres moving in perfect circles. And you might be saying, haha, wait, orbits go in ellipses, not circles. Yes, in this time period, they started to figure that out. Likewise, we've looked at Ptolemy's geography in class. That is a great comparison for the point of view, right? Think about the world view, right? Ptolemy gave us the idea of what the globe looked like, what the map of the known world was. Aristotle and the Christian theologians give us a sense of what they thought the universe looked like. So when we compare these ideas, we have Aristotle's universe here, right, with the earth in the middle on the left. And notice that they are in perfect circles, right? And then Copernicus comes along and goes, I study astronomy and I've realized that we are in orbit with a number of other planets around the sun. The sun is in the middle. It's geocentric. Okay. Sorry, that it's heliocentric is the sun in the middle, right? Geocentric is Aristotle's worldview with the earth in the middle. Copernicus says it's heliocentric. The sun is in the middle. And then Kepler says, okay, but the orbits are not circular. They are elliptical. So your AP gods want you to understand that new ideas and methods in astronomy led individuals like Copernicus, also Galileo and Newton, to question the authority of the ancients and traditional knowledge and to develop a heliocentric view of the cosmos. And so there's a good picture in the McKay text, if you have access to that, that will help you understand the Ptolemaic astronomical system. Basically, what did the Greeks think of astronomy and how they saw the world? Galileo, after Copernicus, is considered a father of observational astronomy. He was an Italian. He was really a father of modern physics and certainly a father of the scientific method. You see him in the picture here. He confirmed the phases of Venus. He discovered the Galilean moons of Jupiter. He analyzed sunspots. He improved the military compass, and he was a champion of Copernican heliocentrism. And one of the things he really is known for are his observations of the moon. And you see here drawings that he made. And this looks like the moon. If you were to draw a picture of the moon, many of you would probably draw drawings quite like this. What was wrong with it, however, was that it showed that there were craters on the moon. The moon was imperfect, like the Earth. The Earth has mountains and valleys. But this goes against that Christian worldview of these perfect spheres that were in the heavens. And then also his telescope is there on the left. So Galileo was persecuted for his ideas. He was investigated by the Roman Inquisition, who said heliocentrism was foolish and absurd in philosophy and formally heretical, since it explicitly contradicts many places in the Holy Scripture. So Galileo was seen as a heretic. He did defend himself, okay, but he appeared to attack the Pope, and thus he alienated the Jesuits, who thought that, who really were going to support him. That had supported him up until this point. Of course, they're the educational branch of the Catholic Church. And Galileo goes on trial, and he was found to be a heretic, and he was forced to recant. And he spent the rest of his life under house arrest, where he wrote his best known works. So we'll stop there. Part 2 is coming up. Stay tuned.